Hi friends, this is soft freezing. This is where we stop from the last lesson. The last lesson where we are able to design our beam. Let's check it. Okay, we are able to design our beam. Okay, and also we were able to design our columns as well. Okay, and so in this lesson, after being designed the structural members, the columns and the beams, we will be looking at the foundation design. Okay, we'll be looking at the foundation design. And so if you are not in the previous two lessons, kindly check the lesson commercial building designs, modeling part, and loading analysis and design part before you can now continue with this particular one, which is the foundation design. As I said earlier, we will be looking at Raft-on beam foundations in this design. Okay, if you have not subscribed, kindly subscribe, like the video, share it as well. Okay, let's start. All right, so we will go to the story 0. Okay, and we will navigate to our plan view. Okay, after which we will save the project. Okay, so after saving the project, we will be inserting our beam. Okay, first before the raft slab. Okay, so for our external walls, we will be using a beam thickness of 450 by 1.5 meter depth. Okay, so that is what we will be using. And for the slab, we will be using a thickness of 250 mm slab thickness. Okay, which is plus the slab cover of 50 mm. We will be having 300 thickness slab. Okay, thickness of slab. So let's go into it. So you click on beam. All right, once you click on beam, this place of 225 we will change it to 450. Okay, and then the depth we will be using 1500 depth. Okay, so we will start inserting our slab, our beam from columns to columns. All right, mind you, when you are inserting beam at the foundation level, ensure that you insert it from column to columns. Okay, all right, so we will have to exit. Once we exit, we will close this. Okay, we go back to beam again, and then we will change it to 225 to 2. At the same depth. Okay, all right, so at this center we will use this thickness. Okay, we are supposed to use this thickness, but since it is a middle beam, let us continue with the 225. Okay, all right, that is it. So after which, the next thing we want to insert our slabs. Okay, so we click on closed, then we go to slabs. Okay, we give our thickness as 250 slab thickness plus the concrete cover, which is 250 plus slab thickness plus the concrete cover, which is 300. Okay, we put 50. Yeah, the concrete cover. Okay, yeah, you use 250. All right, plus this, which is 300. Okay, so you come to loads. All right, this reference level. Okay, you are going to minus 1.5 minus 250 minus 50. Okay, so if you do that, you'll be having a 1.5 minus 300. Okay, so you will be having 1200. Okay, that is to say the height of the slabs from the ground level to the top of the beam is 1200. So we will extract the slabs. This is the foundation slab for the raft. Okay, and so after which we will have to close, and let's look at it in 3D and see what we have done so far. Okay, you right click and navigate to the 3D. All right, so this is what we hope to have at the foundation. Okay, and so the next thing we need to do is we will have to save this project. So after saving the project, the next thing we have to do is we will still navigate to the plan view. Okay, so that we can draw our slab strips. Okay, the slab strips we are going to draw, we come to this point, you will see slab strips. Okay, so we can be able to generate our reinforcement. So we are not going to use analytical strips, but we will be looking at FE strips, which is the finite element strips. Okay, and so we will draw in the x-axis. Okay, this is the x-axis. Okay, so you click outside here, you click here. Okay, and then you click and then you move your cursor across the beam. You can hold your control key so as to have it a straight line. Okay, after which you can now click. All right, to insert your strips. Okay, you also do that in this side. Okay, hold down your control key so you can have a straight line. Okay, if you have any questions on the lesson, drop it at the comment section. You do the same thing here because you are still in the x directions. All right, so we will go to the y direction, so we will do the same thing. Okay, we'll do the same thing here too as well. All right, so after inserting the strips, okay, now it is finite element strips. Okay, so you have to close it. All right, so the next thing we need to do now is to save the project again. Okay, so we will go to analysis. You go to FE Raft Foundation Analysis, which is finite element. Okay, click on it. Once you click on it, you will check this includes column sections. Okay, use subgrade reactions. Okay, you remove this, consider beam torsional stiffness. Okay, and after which you will apply live load reductions to all combinations. Okay, you will leave this. Okay, so you click on Raft Foundation Mesh and Analysis. Okay, All right, so when you click on this, you will have something like this. Okay, so at this point now, you are going to reduce the size of your plate element. Okay, we will use 500 as our plate element. Okay, so after which we will click on generate model. Alright, so after the model is being generated, the next thing we need to do, you have to click on this closed icon so that it can run automatically and transfer to a page where we can carry out the designs. So if you check at this point, you see that slab analysis completed. It is calculating now. So it has transferred to the post analysis processing and reports. Okay, so at this point you click on analysis post processing. Our level cerebral capacity is 90 kiloliters per meter square. That was what we fit in during the analysis. Okay, so you will be having something of this nature. Okay, all right, so we want to give it a contour. All right, we can decide to change the position of the contour. Okay, by clicking on this point. Let's bring it down. Okay, then move this forward. All right, so we'll be having something like this. If you check the loading that is coming at different column, if you check it, you will see it including. Okay, and so the next thing we need to do, we will start the design. Okay, by designing the movement in the global axis. You click on this. All right, you can see this is the movement. Okay, show it in this key. All right, so let's change this position. All right, so we can see it very well. Okay, so you do so by clicking in the my and mxy. Okay, as well. All right, so you will click also movement in the local axis m1, m2, and m12. Okay, then you design movement. Okay, md1 bottom, md2 bottom. Okay, and this as well. All right, so if you move it down, you will now see the area of steel, required steel area. Okay, so let's check the required steel area at the bottom one direction. Okay, you click on it. So the required steel area at the bottom one, we are having the maximum of 1622 millimeter square. Okay, and so we want to assign a steel to this. Okay, and so if you use your table, okay, you use this table. Okay, this is the area of steel. Okay, and so it will depend on this spacing. So let us take our spacing to be 150. Okay, at 150, where can we find that is at y20. Okay, at 150 we find that at y20. So at 175 we find that also at y20. Okay, y20 to be our bottom reinforcement. You know the building is an high-rise building. Okay, so we are having 1623. So at 200 spacing, at 200 spacing, okay, at 100 spacing, we can take it to be y16. Okay, so y16 at 100 spacing. Okay, that is what we will be using. So for us to edit this, we will go to user define contour. Okay, you click on this user define contour. In this user define contour, you can be able to check your concrete cover. Okay, they said they use 56. Okay, so you click on okay. You can now come to this point. You can as well export this contour. Okay, but we want to edit the reinforcement. So at this point now, what we need to do is we will check both. Okay, legend. Under legend, you check both. Once you check both, you click on this T1. Okay, you click on, you check this spacing. You use 100. Okay, so it's giving us 1003 100, just what we have here. At 100 you have that. Okay, so we are supposed to change this to Y16, but unfortunately in the selection what we use, it was only white wave for slab design. So that was what we selected. Okay, so what we need to do now is we will have to close this. Okay, once we close this, we will work with our steel design table. Okay, which we have choose 100 mm Y16, 100 mm spacing at the area of 2100, which is the Y16 bar we are going to use in this raft design at site. Okay, so we will close this. Okay, so let's check the button direction too. Okay, you click on it, we are having 1500, meaning the first area is higher than this, so we are working based on the first area. Okay, at the bottom level of the foundation. So we will click on the top direction one, is even lesser. Okay, so we are going by Y16. Okay, at spacing 100 top and bottom. Okay, so that's it. All right, so we can also come back to this point. All right, we export this contour. Okay, you click on OK. All right, so what we need to do, we'll check the soil pressure. Okay, so you click on this soil pressure. All right, once you click on this soil pressure, what you should be checking now is you'll be placing this cursor along these directions and be checking this point. Okay, look at this point here. Okay, so at this point the soil is okay. You can see they said okay. All right, at this point there is a warning. Okay, there is a warning here. There is a warning here at the column base. Okay, it's okay. Yeah, this point is okay. This point is also okay. So invariably the soil is quite okay, as in there is no punching and there is no failure. Okay, so we will now have to go to the next thing. The next thing we need to do is we want to check the animations of this structure. So you click on this animations. So if you click on this animation, this is the behavior of the structure in respect to the soil pressure. Okay, and the load that is coming on the soil. Okay, so we will now have to close this. Okay, once you close it, the next thing you will do is you will close this. We have finished the design. Okay, so we will close this. Once you close it, take you to this point, you said okay. Once you say okay, to take some time to calculate this finite strips. Okay, it takes some time to calculate the finite strip. You can see transferring slab strips. Okay, it will transfer all the slab strips Y1, Y2 up to Y7. Alright, slab strip has been transferred successfully. Okay, so the next thing you do, you transfer foundations beam result. You click on it. If you check here, we see that foundation beam finite element result are transferred. Okay, so after which you will click on closed. Alright, so once you closed, we want to see our reinforcement here. Okay, and for us to see our reinforcement here, we will need to right click. Okay, then click on arrange steel bars. Okay, then click on slab steel bar. Click on it. Alright, so this is our foundation design. Okay, you can see the slab steel bar has been imported and it has been detailed successfully. Let's check the detailing. This is a top bar here. Okay, alright, this is top bar. The one you are seeing T is top bar, the one you are seeing B is bottom bar 1. Okay, bottom bar and top bar. Alright, so this is how a raft on beam foundation is being designed. Okay, and so the next thing we need to check is our beam. We want to design our foundation beam. So for us to do that, you can come to this point, right click, and then click on this beam design section. Beam section design, you click on it. So you notice that the beam has not been designed. You can also come through this point. You will go to ROC design, and then you come to beam section design and detailing. Come to foundation. It will also take you to the same place. So what you need to do here is you will click on beam design bash mode. Once you click on it, you click on calculate. You are asking the program not to select another state. That's why this place is checked. Okay, All right, so you closed. So once you run that analysis, you click on it and click on interactive design. Okay, after you click on interactive design, you can extend this. Okay, you have a 6y system here and 2. Yeah, okay, so you can extend it to the anchorage. Okay, you can see extend also the site to the anchorage, as in to the support. Okay, so that is it. Click on OK. You notice that it has changed good, meaning this particular beam has been designed successfully. You do the same thing here. Okay, or this one, this point, you extend, sorry, you extend this point and this point. Okay, and then you will look at this also point, you extend it. Okay, you click on OK. You can see it's been designed successfully. Okay, so that is how you can run your foundation beam design. Okay, so you will do the same thing here. Mind you, if you have any question regarding this lesson, please kindly drop it at the comment sections. Okay, and also if this lesson has helped you in one way or the other, kindly support the channel by subscribing. Okay, for notification as soon as I upload any videos. Okay, and so this is the last one. Okay, so all our beams has been designed now, the foundation beam designed successfully. Okay, so you click on the close button. All right, so you will be having something like this. So we have been able to design our foundation beam successfully. We have designed also our foundation slab, okay, successfully. All right, so we will be going to the first floor slab. Okay, we will save the project first. All right, so if this lesson has helped you one way or the other, kindly subscribe. Okay, kindly subscribe. So we will navigate to the first floor plan. Okay, so we will be inserting the strips for this on this first floor. Okay, so the strip you are going to be considering now is the analytical steel. Okay, strips. Okay, so we go to strips. Okay, and then in the x directions we will select this point and then select analytical strip. Okay, so you click at this point, you move your cursor across, hold down your control key to have a straight line. Okay, and so you click. Once you click, you see your strips has been inserted successfully. Okay, you do the same thing here. Hold down your control key to have a straight line. Okay, so you click to insert your slab strips. Okay, for this first floor, mind you, these slab strips will be applicable to other floors. Okay, so you do the same thing in this panel. All right, so we will be using slab to slab. Okay, slab to slab. So we can insert strips here. Okay, so we click inside of this slab. Okay, and we cut across. Okay, and click. All right, that is it in the direction x-axis. Okay, so okay, let's extract it here. This is bob to slab. Okay, you click at this point. All right, so we'll go to the direction y-axis, and then at that point we will use bob to bob. Okay, which is outside to outside. Okay, and you click to insert it. All right, you do the same thing. Yeah. All right. All right, so this strip that we have extracted here will be applicable to other floors. Okay, so we have to close here. So the next thing we will do, we want to get our drawings. Okay, so we will click on save first. Save the project. Okay, so after saving the project, we will navigate to the ROC design. Okay, which is reinforced concrete design, and then we will click on this Prota detail. Okay, we click on Prota detail. You click. But mind you, if you want to print a report for this slab, okay, you click on this. You go to slab. Okay, right click and then you click on set slab analysis, set slab type analytically. Okay, and then you click on slab analysis and design. Okay, to run this design. Okay, they say check design, do not modify existing scene. Okay, you click on our story. Okay, and you click on design. Alright, this slab has been designed. So this is the design calculation sheet for this slab. Okay, you can see the bar is sufficient. Okay, if it's failing, they will tell you deflection check L over D equals to 10 point this less than this. Okay, you could have said insufficient if it's failing, but it is sufficient, meaning it's passing. Okay, so that is it for slabs design. Okay, so this is a kind of report. Okay, that you can attach to your drawings. Okay, so you close this. How you get a slab report? Okay, you close this point. Okay. Alright, so the next thing you need to do, we need to transfer this to the Prota detail, so as to generate detail for our beams and our columns as well. Okay, so you click on ROC design. Okay, and then you click on Prota detail. Okay, so the Prota detail 2018 has launched. Okay, so this is the Prota detail interface. Okay, alright, you can see the project commercial building designs lessons. Okay, and so the next thing we need to do, we can't just start by creating a new drawing. Okay, as in we start by creating a sheet, but I always prefer using auto generate details. Okay, so you click on auto generate details. So a dialog will show. In the dialog, the only thing I can't check here is this column dimension. I only check this column dimension. You can see the scale of the drawings. Okay, you can increase it to 1:100, but we'll be using 1:50. Okay, in this lesson. Okay, so you click on draw. So once you click on draw, you just click at any point on this drawing board. Click on it and allow it to load. Okay. Alright, so it is generating our drawing as you can see. Okay. So the drawing has been generated successfully. Okay, so this is the foundation slab detail. Okay, which you can't export it to AutoCAD and then be able to edit it. Okay, this is the first floor slab. Okay, so it comes with bar bending schedule. You can see the bar bending schedule. Okay, and also these are the columns design and the bar bending schedule, column details. Okay, if you check here, you can see the schedule. Okay, of columns. Okay, these are the schedules of columns. All right, the schedule of columns. So this is our beams. Okay, this is our beams. All right, so this is a complete design. You can see the incline beams. All right, these are the incline beams. Okay, that one that carry the solar panels. Okay, so this is a kind of a complete design of a commercial building. Okay, so what you need to do now is you just have to come to this point, click on this point, right click, okay, and then click on export. Okay, it will export this drawing to in form of AutoCAD version as in DWG version 2010, but I will save it in version 2007. So any version that is above 2007 can be able to open it. Okay, so you click on export. You see that it is loading here. Okay, so it will take some time to load at this bottom. Okay, if this lesson has helped you, kindly subscribe. I know that this lesson must be a help to you. If you have any questions, drop it at the comment sections. Okay, so okay, after it loads, finish loading, it has transferred to the folder where the drawing is located. So you just click on it, and then you can launch your AutoCAD. So as to view those drawings in AutoCAD for further editing. Okay. Alright, so these are the drawing in AutoCAD now. Okay, so with this you can now be able to edit your drawings. Okay, and print them. Okay, so if this lesson has helped you in one way or the other, kindly support the channel by subscribing. Okay, so this is where we are going to stop for now. So kindly subscribe, share the video, okay, and like the video. Bye for now.